This question is about the free fall motion of three stones. And as you see in the diagram, these three stones have masses m, 2m, and 3m respectively. And we are throwing it with the velocity v, initial velocity, and its velocity is 2 times of that. So 2v and its velocity, initial velocity, vertical velocity is 3 times, right? So that is 3v. Question is that if we assume that there's a no air resistance which makes it free fall motion, okay, so what will be the rank from the high to low maximum height of each ball? That's written here. So which stone will attain more height, which stone will cover more vertical distance? Okay, so what is a common between these three? The one thing is common, that both, like all of them, are free fall motion. So when all of them are free fall motion, so you know very well that for this uniformly accelerated motion, we can apply kinematics equations because acceleration is constant. And if you look in kinematics, all equations, the Vy is equals to Vy0 first equation, then the second equation, initial velocity t plus 1 over 2 acceleration time t square. Then the third equation, that is Vy square is equals to initial velocity square plus 2 times acceleration times the displacement covered. All of these equations, we don't see any relation between all the quantities with mass. Okay, which means that mass has a no importance. Mass has, because the reason is that the mass of this stone is comparably nothing when we compare it with the mass of Earth. Okay, so that's why in the gravitational field near the Earth, this mass of this stone is has a no significance. So now we also don't know that what is the time that which stone is taking how much time. So that's why we should use such an equation in which we don't have to use the time. So which one is more suitable? That is of course this one. So let's use it. And by the way, you can also count in this one the average velocity, right, times the time taken. Even in this equation also mass is not important. Okay, now, so I was saying that we are going to pick this equation, final velocity square plus initial velocity square plus 2 acceleration times the vertical displacement covered. Okay, so it's 0 because all the stones will attain 0 meter per second at the maximum height, so that is 0 is equals to Vy0 square plus 2 into negative g delta y, right? And delta y is basically y, that's the maximum height minus initial height if they are released from the, if they are thrown from the ground, that's why it is 0. Okay, so we are now successful to make a relation between the initial velocity, okay, and the and the displacement covered. So that will be 2gy is equals to Vy square, initial velocity square. So what we find from here, that the distance covered is equals to square of initial velocity divided by 2g, which tells us that the distance covered by every stone is proportional to its initial velocity square. So we can directly make a proportion. What do you think? That y3 ratio y2 ratio y1 should be equals to 9 ratio 4 ratio 1. Okay, because if it has a 3v, so it will acquire, like, its height is proportional to 9v square. Okay, it's proportional to 4v square when we will take square of initial velocity, and that is proportional to v square. So of course the 3 is the highest, second, and then 1, so option C must be the right answer.